Hello again. Now we'll look at the different colors of hydrogen and how the used energy source affects the color. Hydrogen is a versatile energy carrier and an important chemical for the chemical industry that can be produced from various sources using different technologies. The production method determines the environmental impact, cost, and efficiency of hydrogen, which is why hydrogen is often categorized by color. These colors represent different production processes and their carbon footprint. The sustainability of hydrogen depends on how it is produced, with some methods being more environmentally friendly than others. Let's first look into gray hydrogen. Hydrogen itself is always the same, but the color tells us about the way it is produced. Gray hydrogen is made from fossil fuels, most often natural gas. The main method is called steam methane reforming. In this process, natural gas, which is mostly methane, is mixed with very hot steam at around 700 to 1000 degrees Celsius. The heat and steam break the methane apart into hydrogen gas and carbon monoxide. In a second step, the carbon monoxide reacts with more steam to create even more hydrogen, but also carbon dioxide. This method is cheap and well established, which is why it is used on a very large scale today. In fact, most of the world's hydrogen is still produced this way. But the big problem is that all of the carbon dioxide produced is released into the atmosphere. That makes gray hydrogen a fossil-based fuel with a large carbon footprint. Next, we'll talk about blue hydrogen. Just like gray hydrogen, it is produced mainly from natural gas, using the process called steam methane reforming. Methane reacts with hot steam to produce hydrogen and carbon dioxide. The important difference is that, in blue hydrogen production, the carbon dioxide is not simply released into the atmosphere. Instead, special technology is used to capture the CO before it escapes. This is called carbon capture and storage, or CCS. The captured CO can then be stored deep underground, for example in old gas fields, or used in some industrial processes. Because the carbon dioxide is captured, blue hydrogen has a smaller carbon footprint than gray hydrogen. It is sometimes called a bridge solution, because it uses existing fossil fuel technology but tries to make it cleaner. Now let's look at green hydrogen. Unlike gray or blue hydrogen, green hydrogen does not come from fossil fuels. Instead, it is made using renewable energy sources, such as wind, solar, or hydropower and water. The production method is called electrolysis. In this process, electricity is passed through water, splitting it into hydrogen and oxygen. The hydrogen is collected as a clean fuel, and the oxygen is simply released into the air. If the electricity comes from renewable sources, the whole process produces almost no carbon emissions. That's why we call it green hydrogen, as it's the most environmentally friendly option. Green hydrogen is often seen as the future of hydrogen production, because it can provide clean energy for industries, transport, and even heating, without adding greenhouse gases to the atmosphere. Now let's look at turquoise hydrogen. This type of hydrogen is made from fossil fuels, usually methane or natural gas, but with a different method compared to gray, blue, or green hydrogen. The process is called methane pyrolysis. In methane pyrolysis, natural gas is heated to very high temperatures in the absence of oxygen. Instead of forming carbon dioxide, the carbon in the methane separates out as a solid material. This solid carbon is much easier to store or use than carbon dioxide gas. For example, it can be used in industries to make products like batteries or construction materials. Because no carbon dioxide is released, turquoise hydrogen can have a much smaller impact on the climate. But it depends on how the high heat for the process is produced. If renewable energy is used, the process can be quite clean and its footprint very small. Next, there's pink hydrogen. Pink hydrogen is produced in the same way as green hydrogen, through electrolysis, where electricity splits water into hydrogen and oxygen. The difference is in the source of electricity. For pink hydrogen, the power comes from nuclear energy. Nuclear power plants can provide a steady, reliable flow of electricity, which makes them well suited for running electrolyzers day and night. Because nuclear energy does not produce carbon dioxide while generating electricity, pink hydrogen is considered a low-carbon option. It can be especially useful in places where renewable energy like wind or solar is not always available, but where nuclear energy is part of the energy system. Though it is not producing carbon dioxide, its waste is considered a challenge. Nuclear energy creates radioactive waste that must be carefully stored and managed for thousands of years. Because of this, pink hydrogen is sometimes debated. It is low carbon and reliable, but it comes with concerns about safety, waste storage, and public acceptance. Still, many see pink hydrogen as an important option for producing clean hydrogen, especially in countries that already have nuclear power plants. Now there's left the brown hydrogen, also called black hydrogen. Brown hydrogen is produced from coal, especially lignite. When harder and darker coal, like bituminous coal, is used, the product is often called black hydrogen. The production method is called coal gasification. In this process, coal reacts with oxygen and steam at very high temperatures. The result is a gas mixture called syngas, which contains hydrogen, carbon monoxide, and carbon dioxide. From this mixture, hydrogen can be separated. However, this method produces large amounts of carbon dioxide. In fact, brown and black hydrogen are the most polluting types of hydrogen production, because coal has a high carbon content compared to natural gas. The released CO contributes heavily to climate change. Some countries still use coal gasification, because coal is cheap and widely available. But from an environmental point of view, brown hydrogen is not sustainable, as it produces very high carbon dioxide emissions, and it is considered the dirtiest hydrogen option. Now we have learned that hydrogen can be produced in several different ways, and each method has its own benefits and challenges. Let's compare them by looking at 3 key points: emissions, energy sources, and costs. Grey hydrogen is made from natural gas using steam methane reforming. It is the cheapest and most common method, but it releases a lot of carbon dioxide into the atmosphere. This makes it a high-emission option. Blue hydrogen also comes from natural gas, but here the carbon dioxide is captured and stored with carbon capture and storage (CCS) technology. This lowers emissions compared to grey hydrogen, but CCS increases the cost, and it does not remove all of the CO. Green hydrogen is produced by splitting water using electrolysis powered by renewable energy sources like wind or solar. It has almost zero emissions if renewables are used. The challenge is cost, as electrolyzers and renewable electricity are still expensive, though prices are expected to drop in the future. Turquoise hydrogen is made by methane pyrolysis, which produces hydrogen and solid carbon instead of carbon dioxide. Solid carbon is easier to handle than CO gas, and it can be used in industry. The emissions depend on how the high heat for the process is generated. Costs are currently higher because the technology is not yet widely used. Pink hydrogen is similar to green hydrogen, but the electricity comes from nuclear power. It has very low carbon emissions and provides a steady, reliable energy source. However, it is linked to nuclear waste management, and the costs depend on nuclear energy availability. Brown or black hydrogen is made from coal through gasification. It is the oldest and cheapest method in some regions, but it also produces the highest carbon dioxide emissions. Because of this, it is considered the least sustainable option. As a summary, the cheapest methods today are grey and brown hydrogen, but they cause the highest emissions. Blue hydrogen is cleaner, but costs more. Green and pink hydrogen are the cleanest options, but today they are still the most expensive. Turquoise hydrogen could become a good middle option if the technology develops further.